A port goes on strike. The gantry cranes stop. Upstream supply freezes completely. For a few tense weeks, your company holds its breath. And then, the strike ends. You look at the balance sheet, and your business is still shipping product. The immediate reaction in the boardroom is relief. Executives point to their business continuity plan, their BCP binder, and declare that the system worked. You faced a crisis, and you are still operating. But the paperwork in that binder didn't keep the lights on. If you look closely at the supply chain data, you survived by sheer luck. Your accidental, leftover inventory buffer simply happened to outlast the duration of the strike. Business continuity planning is a necessary operating discipline, but at its core, a BCP is a reactive manual written for the last disaster. It dictates who to call and how to evacuate, but it cannot predict the duration or shape of a novel crisis. True supply chain resilience is entirely different. It is a proactive, mathematically driven structural design. It measures exactly how long a specific node can fail before the entire network collapses. Assuming that surviving one disruption guarantees safety from the next is a dangerous executive illusion. Relying on an accidental buffer subjects a company to a strict law of mathematics. Eventually, the numbers catch up, and the equation ends in ruin. This timeline maps the two variables that actually dictate your risk exposure. Forget vague impact scores. Real resilience comes down to time to recover, or TTR, and time to survive, or TTS. Time to recover is the exact number of days it takes a broken supplier node or damaged facility to return to full 100% functionality. It is your disruption clock. Time to survive is your stamina. It measures the absolute maximum duration your supply chain can match supply with customer demand, using the inventory you have and the alternative sources you can immediately switch to. The problem appears when we compare the two. This negative space is the fatal gap. It is the mathematical deficit created when a node's recovery takes longer than your company's ability to survive. If a disruption pushes your timeline into this zone, you run out of parts before the supplier comes back online. Catastrophic revenue loss becomes a structural certainty. No amount of boardroom improvisation can fix it. Supply chain exposure is an unclosed mathematical equation. If your time to recover is greater than your time to survive, your business is designed to fail. We can see this exact equation play out in March of 2000. Both Nokia and Ericsson relied heavily on a specific Philips manufacturing plant located in Albuquerque, New Mexico. A 10-minute fire broke out in a sterile cleanroom. The blaze was extinguished quickly, but the smoke ruined millions of critical microchips, instantly choking the global supply for both telecom giants. Ericsson reacted by following standard continuity protocols. Their information took weeks to escalate up the chain of command. They severely underestimated their time to recover, leaving their time to survive at near zero. That delay resulted in an estimated $400 million revenue loss, eventually forcing them out of the standalone handset market. Nokia took a different path. They calculated immediately that their time to recover from this single plant was massive. To close the gap, they proactively expanded their time to survive, aggressively locking up alternative global supply and re-engineering their phones to accept substitute chips. Nokia deliberately manipulated their survival variables. Ericsson waited for the system to correct itself. Resilience requires active engineering, not blind faith in a document. To survive the current risk landscape, building resilience can no longer be delegated as a side project for the procurement team. It has to become a core portfolio design principle, driven by the C-suite. The immediate instinct is usually to hoard inventory, to stockpile materials just in case. But expanding your safety stock blindly traps critical working capital in warehouses without actually addressing the weak links in your network. This network graph illustrates the modern playbook. The first step is deep tier mapping. You have to trace your critical bills of material down to the Tier 2 and Tier 3 suppliers to find the single points of failure before they break. Next, you quantify your survival gap. Using digital twins and AI-driven stress tests, you simulate disruptions to measure exactly how much value is at risk. You map your vulnerabilities in a safe digital environment before spending $1 of capital. Finally, you redesign the physical network. You close the fatal gap by shrinking your recovery time through dual sourcing. or you extend your survival time through flexible product design and alternate logistics routes. The choice for leadership is clear. You can treat continuity like an optional insurance policy, hoping your accidental buffers outlast the next crisis. Or you can restructure your operating model to remove the fragility entirely. Engineering a supply chain to absorb, adapt, and recover is no longer a strategic luxury. It is the strict mathematical baseline required to stay in business.